Welcome back to the deep dive. I want to start today by ignoring the headlines everyone else is talking about.
Mm.
Because while the rest of the tech world was, distracted by chatbots writing poetry or generating those surreal videos, something much more fundamental shifted at Microsoft. This was between January 18th and the 25th.
It was a deceptively quiet week if you only looked at the consumer apps.
Right.
But if you look at the plumbing, the research papers, the developer tools, you could argue it was the most significant week of 2026 so far.
I'd describe it as a nervous system transplant. I mean, we aren't talking about chatbots anymore. That word feels obsolete after looking at this stack of sources. We are talking about agents.
Yes.
And not just the buzzword version, but the actual mechanics of giving AI a physical body, a visual cortex for screens, and an operating system to live in.
That is exactly the right way to frame it. We've moved from text in, text out to perception, planning, and action. We saw robots learning to field texture. We saw software agents get their own cloud computers.
And the infrastructure being laid to support millions of these things running at the same time.
Exactly.
So we have a lot to unpack. We're going to cover the new robotics research, the huge shift in developer tools with the new Agent SDK, the Agentic scale infrastructure, and, well, the security nightmare that comes with letting autonomous bots loose.
And we've got some very fast cars and a massive legal project in India to get to.
Can't forget the fast cars. But let's start with the body. On January 21st, Microsoft Research dropped a paper on something called Rho-alpha. At first glance, it looks like just another robot model, but the architecture is different. They're calling it VLA plus GAP.
Vision language action plus tactile. And that plus is doing a lot of heavy lifting.
Okay, so what does that mean?
For the last few years, robotics has been dominated by vision. The robot looks at a cup, it calculates the geometry, and it tries to grab it. But vision is distant. It doesn't tell you if the cup is slippery or if you're crushing it.
Right, that's the classic paper cup versus ceramic mug problem. You squeeze a paper cup with the same force as a mug, you get coffee everywhere.
And if you treat the mug like a paper cup, you just drop it.
Exactly.
And that's where Rho-alpha changes the game. It introduces tactile embedding. So it's not just processing pixels anymore. It's processing physical feedback, pressure, vibration, texture, and turning that into data the model actually understands.
And it's bimanual, so it uses two hands, learning from human feedback.
Yes, cooperatively. It feels like the bridge between, simulated AI and physical AI.
Simulation is clean. The real world is messy.
So messy.
Yeah.
And by solving for tactile feedback, they're trying to let the AI function in that chaos. It's no longer just watching the world. It's physically interacting with it, adjusting its grip in milliseconds based on what it feels.
Not just what it sees.
Precisely.
Okay, so speaking of seeing, let's pivot to the digital eyes. On the 18th, Microsoft Research Asia released the Phi-Ground research. This gets at a frustration I think we all have. AI is still pretty terrible at actually using computers.
It's the grounding problem.
Yeah.
You can ask an LLM to click the send button, but an LLM, it just deals in tokens and text.
Right. It doesn't know that the send button is at pixel coordinate 1224 by 768 on your specific monitor. It knows the concept of a button, but not where the button is.
Exactly. So the team released a benchmark called UI-E2I Synth. What they did was they used GPT-4o to synthesize nearly 10 million instruction screenshot pairs.
10 million.
10 million. It's basically a massive training curriculum showing the AI, when a human says this, they want you to click here.
It's a huge data set.
It had to be. They use it to train their new model, UI-I2E VLM7B. It's a mouthful, but the result is what matters. It's a 7 billion parameter model, which is pretty small these days.
Oh yeah, tiny.
And it outperformed the previous state-of-the-art methods that used way more data.
That efficiency is so important. If we want an agent running locally on our laptops, navigating apps for us, it can't be some 100 billion parameter model eating all our RAM.
It needs to be small, fast, and accurate. And this is effectively a visual cortex for digital agents. Before an agent can file your taxes, it needs to be able to see the tax software, recognize that messy UI, and click the right box. Phi-Ground is the research that enables that.
So we have the hands with Rho-alpha and the eyes with Phi-Ground. Now we need the brain, or at least the nervous system connecting it all. For developers, the biggest news of the week, maybe the year, honestly, was the GitHub Copilot SDK launch on January 22nd.
This is where we see the commoditization of agency. I mean,
The
up until last week, if you wanted to build an autonomous agent, something that plans and executes tasks,
Yeah.
you were writing so much glue code.
Right, you had to build that whole loop yourself. Plan step 1, execute step 1, check for errors, plan step 2.
It's complex. It's fragile. You spend more time building the engine than driving the car.
So what does the SDK do?
It exposes that planning and execution loop as a library. It supports Node.js, Python, Go.net. It lets any developer take the core logic that powers GitHub Copilot and just embed it into their own application.
That is a massive shift. So a developer for, say, a travel app doesn't need to be an AI researcher. They just grab the SDK and say, okay, here are the tools for booking flights and hotels. You handle the planning.
It standardizes the behavior. We are moving from everyone building their own custom, frankly, janky agent architectures to a standardized agent OS provided by Microsoft. It just lowers the barrier to entry so much.
And staying on GitHub for a second, I noticed a detail in the CLI, the command line interface update from the 21st that almost slipped by me. They introduced a plan mode.
Right, access with Shift plus Tab.
But the specs mention GPT 5.2 codecs. Did I read that right? GPT 5.2.
You did. It's a very quiet reveal, which is typical of how they test these things in production. We haven't seen a big press release for a GPT-5 base model yet, but they are deploying a 5.2 variant for coding reasoning right there in the CLI.
So the model is already active, just scoped to very specific tools.
It is. And in that plan mode, it uses that reasoning power to proactively fix things. They added slash commands like test to generate test suites or fix to debug errors.
But you told me the most important feature was something else. Repository memory.
Yes. For me, this is the key.
Is that just remembering that I like my brackets on a new line, or is it deeper?
It's much deeper. It persists the conventions and the architectural patterns of your specific codebase. So if your team always structures API calls in a certain way or uses a specific library for error handling, the agent remembers that across sessions.
That's the difference between a temp worker and a full-time employee. The temp asks, how do we do this? Every single morning. The employee just remembers.
And that persistence unlocks real productivity. You stop fighting the AI on style and you start collaborating on logic.
Okay, but this brings up a massive scale problem. If we have millions of these agents, all using repository memory, constantly reading code bases, creating plan modes, navigating UIs, that is a staggering amount of data I/O.
It's a data tsunami. And it's a different kind of data traffic than we're used to.
How is it different?
Well, humans stream data. We watch a movie, we scroll a feed, it's sequential, agents are noisy, they do these random access reads and writes constantly.
Okay.
They'll query a vector database, then read a file, then write a log, then query again thousands of times a second.
Yeah.
Your standard cloud storage just chokes on that.
Which is why, on January 22nd, the Azure Storage team released their roadmap for Agentic scale.
They had to. They announced Azure Managed Lustre scaling to 25 petabytes with a throughput of 512 gigabytes per second.
Hold on. 512 gigabytes per second. That is just absurd.
It sounds absurd, but it's necessary. If you have 1,000 agents trying to learn from a single data set simultaneously, you need that kind of throughput. Otherwise, the agents spend 90% of their time just waiting for data.
So this infrastructure is what makes Agentic AI possible beyond just a demo.
It's the only reason it can scale.
And it seems they're also rethinking where these agents live. On the same day, they announced Windows 365 for agents.
This was one of the most futuristic announcements of the week, I thought.
Right. We're used to Windows 365 as a cloud PC for remote workers. This is a cloud PC for non-human workers.
Exactly. Because if I have an agent navigating a GUI to process invoices, I do not want it hijacking my mouse and keyboard while I'm trying to work.
You want it running headless, or at least on a screen you don't have to look at.
Windows 365 for agents gives the bot a secure, isolated environment. It's literally a digital cubicle. The agent logs in, does its work in the cloud, and then logs out.
Which brings us perfectly to the part of this that makes me nervous. We're giving these agents their own computers, their own memory, the ability to execute plans. That sounds like a security nightmare.
It is the defining security challenge of 2026. On January 20th, Microsoft's security team laid out their priorities, and they explicitly flagged agent sprawl.
Agent sprawl. It sounds like something from a sci-fi movie.
A plague. Well, it's the risk of having thousands of autonomous processes running on your network with no clear oversight. If an agent has permission to buy server capacity or delete a database and it hallucinates
or gets hijacked,
the damage is instant.
So the solution they're proposing is identity-centric defense.
Zero trust for robots. Every single agent needs a verified cryptographic identity. You don't just trust it because it's running on your internal server. You verify every single action it takes against a policy engine.
It's like, show me your ID badge before you touch that file.
And it goes even deeper, verifying that the agent itself hasn't been tampered with. We saw an out-of-band update for Windows on the 24th KB 5078135.
Yeah, that stuck out to me. Usually you wait for Patch Tuesday. An out-of-band update means fix this immediately.
Right. It shows that AI is now a critical dependency deep in the operating system. If the AI layer has a vulnerability, it compromises the whole system. We are going to see a lot more of these emergency patches.
And Microsoft is trying to set the rules at a global level, too. On the 20th, they announced that UN80 Innovation Fund partnership. This felt different than a donation. It felt like a treaty.
It really highlights Microsoft's geopolitical weight. The UN is trying to modernize, and Microsoft is stepping in to provide the infrastructure. But the interesting phrase in that announcement for me was dual literacy.
Meaning what, exactly?
Meaning, policymakers need to learn how the tech works, but developers need to learn ethics.
Okay.
Microsoft is acknowledging that you can't govern this stuff if the people making the laws don't understand what an inference run even is. They're positioning themselves as a sovereign peer to the UN in shaping these regulations.
Okay, so we've covered the what and the how. Let's look at the who. Who is actually trusting this agentic infrastructure today? Because on January 22nd, we got a very, very high-speed answer.
The Mercedes-AMG PETRONAS Formula 1 team.
I love an F1 example because it just cuts through all the marketing fluff. You can't fake performance on a racetrack.
You really can't. An F1 car today is basically a server on wheels. It generates 1.1 million data points per second across more than 400 sensors.
1.1 million per second. That's not just big data, that's violent data.
It is. And Microsoft and Mercedes renewed their partnership to have Azure handle that entire stream. They're using it for aerodynamic simulations, for real-time race strategy.
So this proves that the agentic scale infrastructure we talked about isn't just theoretical. If Azure can ingest that much data from a car moving at 200 miles per hour and run inference on it to tell the driver when to pit,
then it can probably handle your company's inventory database.
Exactly.
It's the ultimate stress test. If the infrastructure hiccups for even a second in F1, you lose the race. It builds a ton of confidence for enterprise customers.
Speaking of high volume, let's look at the legal system in India. On the 21st, there was a story about reducing the backlog of court cases.
This is a staggering number. India has a backlog of roughly 46 million legal cases.
46 million. That's a humanitarian crisis of delayed justice.
It is. So Microsoft partnered with SCC Online and a firm called TriLegal to deploy AI assistance. But here's why the tech actually matters here. It's not just keyword search. It's using contextual reasoning over 4 million judgments.
So it's not just finding documents with the phrase land dispute. It's finding documents where the concept of a land dispute matches the specific legal precedent you're trying to argue.
That is the shift. It's parsing the reasoning of previous judges. By automating that part of the research, they hope to chip away at that 46 million case mountain. It's a prime example of AI for good that relies on an agent's ability to understand context.
Not just match text.
Right.
And finally, we saw Board Agents launch on the 21st. And just to be clear for everyone, Board is the name of an enterprise planning platform.
Right. And they launched agents specifically for finance, FP&A, supply chain, and merchandising. This is important because it shows specialization. We aren't seeing a general manager AI. We're seeing a supply chain specialist AI.
It's the org chart coming to life in code.
It really is. These agents are built on Microsoft Foundry, and they're designed to live inside the specific workflows of those departments. It just reinforces this idea that agents won't be one-size-fits-all. They'll be highly specialized tools.
So if we look at the full picture from this week, we have robots that can feel with Rho-alpha, eyes that can see screens with Phi-Ground, a nervous system to build them on with the Copilot SDK.
A brain that remembers with a CLI repository memory, and a cloud infrastructure with Azure Luster and Windows 365 to house them all.
It's the industrialization of the agent. We've moved past the wow, look at this chatbot phase. We are now pouring the concrete and laying the cables. Microsoft is building the factory floor for a digital workforce.
That's the takeaway. The infrastructure is now ready for digital employees.
Which leaves me with a final thought for all of you listening.
What's that?
If these agents have their own... At what point do we stop calling them software and just start putting them on the org chart?
And maybe more importantly, if you're a manager, Are you ready to conduct a performance review for a piece of code?
That is a reality coming much faster than we think. Thanks for listening to this deep dive. We'll see you next time.